in addition to arithmetic operations, if you're allowed to do Pfaffian function computations, so your algorithm takes in your parameters, it can do addition, multiplication, all that rational computation stuff, but it can also apply at any point a Pfaffian function to any of its arguments or any of the previously computed values, and then it uses that to perform whatever it's doing, like computing a cluster or a matrix or whatever, regression, and then you can give a bound on the pseudo dimension in terms of the length of the Pfaffian chain, which is q, degree, and the Pfaffian degree. So as long as if you can bound those quantities, if you can come up with a chain to bound those and bound the degrees, then you can give a bound on the pseudo dimension of the GJ algorithm, which is used to compute. I'll remind this and give an example of this after the break. But if there are any questions about this, why do we care about this? Is there a question?
How big is the
Wait one sec for the microphone.
How big is the set of Pfaffian functions? Are there bigger than the? I imagine they're bigger than smooth functions, for example.
Right. So Pfaffian functions, yeah. I mean, Pfaffian functions, even rational functions can be non-smooth, right? So you can define polynomials or rational functions which have very large slopes. So they are definitely bigger than the class of smooth functions. They include a lot of non-smooth functions. But the interesting, maybe another way to go about it is to give exceptions to things that are not Pfaffian. Things like maybe sine function is not Pfaffian because if you take the derivative, you get a cosine, which cannot be expressed as a polynomial of sine. So there are examples of functions which are not Pfaffian, but these functions have unusual behaviors. Like, for example, the sine function has sort of infinitely many oscillations. While more regular functions like exponents, logarithms, or polynomials, you have a bounded number of oscillations. There's sort of another maybe intuitive connection between why we're able to bound their pseudo dimension, because they have certain boundedness properties, but those boundedness properties are related to the number of oscillations and other properties that are relevant to proving pseudo dimension bounds.